Our first presentation is by Kim Wolf. Kim has extensive experience in consumer goods manufacturing and food processing. She has worked with Pepperidge Farm in the US, managing manufacturing facilities that produced various food products, and has held roles as manager of engineer and maintenance, as well as operations manager, before being transferred to Canada as the plant manager at the Campbell Soup plant. As a consultant, Kim has worked with manufacturers to introduce and integrate appropriate tools into businesses, ultimately driving superior bottom line results. Today, Kim will be discussing CI tools and calculations for downtime and uptime. After Kim's presentation, we will open the virtual floor for any questions. If you have any questions during or after the presentation, feel free to post them in the Zoom questions box below. Welcome, Kim. Over to you.
Thank you so much for having me. I'm so excited to be here today. I am going to, as I looked at the other presenters today, I thought, oh my gosh, I mean, what I have to talk about today with maximizing uptime, in some ways, is very basic compared to, I know, our presenters that are going to be presenting a little bit later on. I will start let's see here. I will start, if hopefully I can start with a little bit about myself. So I grew up in Pennsylvania, went to Penn State for mechanical engineering and math. So you will see that throughout the presentation today, I will talk a lot about data. And I think that's just the engineering geek in me that likes data, likes numbers. But really, that's what we're all about. We're all about making money. That's why we're all in business. So to do that, we have to follow through with the numbers and the data. So that will help us to work on the right things. As you mentioned, I worked for Pepperidge Farm. I've also worked for some other companies, both in the US and in Canada. I was transferred from the Campbell Soup Pepperidge Farm division up to the Campbell's division in Canada. That's what took me up to Ontario. And so I've been up there for 20 years and have had some other experiences with companies up in Canada. And I have done some teaching at Conestoga College in food processing technology, and then also developed a post-grad program for operations leadership. I'm a huge believer that those things go together. I think that many of us are perhaps good at one and not necessarily the other. When you find people on your team that are good at both of those things, at understanding food processing, understanding the reliability, maintenance, all of those things, and can be a good leader, I think those are the people that are really going to make the biggest impact on your teams. I now have my own business doing leadership coaching and manufacturing consulting. As I said, I kind of do, I think I have a hand in each one of those buckets, and have really been very thankful for many of the opportunities that I've had throughout my career. Lots of opportunities, from starting a greenfield site for a plant that made frozen cakes, all the way to starting world-class maintenance programs at several different companies when I was a maintenance manager, and then, of course, my teaching. So I'm trying to put all of that together and to help other companies now to do that. So we're going to talk today about how do we optimize uptime. And it really, when you optimize uptime, what goes along with that is minimizing downtime, of course. So there's a few different things we're going to talk about today. The topic of optimizing uptime is so broad, and we could talk about it for just hours and hours. But we're going to focus today on some continuous improvement tools. Many of those, some of you are going to say, yep, I already know all this. I got that. I've either done it before or, it's in our toolbox to do. But I really believe that the tools that we're going to talk about today are very basic. They're easy to use, whether you are a small company of 5 people or a very large company of thousands of people. The tools can be adapted very easily. I'm a huge believer of employee empowerment. And so using these tools to drive results from your production floor is so important. I know there's lots of analysis that happens in the conference rooms and, on finance computers, and that's all good stuff. But where you're going to see your actual results immediately will be from using these tools out on the production floor. We're also going to talk about preventive and predictive maintenance tools. Again, I've seen these tools work tremendously, and that journey to get from firefighting to preventive maintenance and ultimately to evolve into predictive maintenance is such an exciting journey. And so many companies are still in that firefighting mode. There's so much out there that's available. And again, I know that people know that, but actually starting to implement it where it can have an impact to your business, where you are reducing that downtime, is so important. And then, of course, we'll talk about measurements. So what are the appropriate measurements to use to baseline your results and then to track progress? And this also doesn't have to be fancy. They are things that you can do, at a very base level, even out on the production floor. So this I had remembered reading in MRO magazine a few months ago, this information, and it is that 68% of in businesses in Canada experience unplanned outages at least once a month. And the value of that costs Canadian businesses about $242,000 per hour. So that shows you how impactful downtime can be. In that same article, which I have a link here on the presentation if you would want to go back and read this article again, but it talks about industrial businesses needing to aim to really get rid of that high-risk run-to-fail maintenance approach that so many of us still use, and go to more of a long-term strategy. You're going to improve reliability, business reputations, and of course, ultimately make money. And that's what we're all here to do. So continuous improvement really, there's several stages of it. I found that this figure here that I'm posting it really emphasizes where facilities are. Stage one is really in the firefighting. So you're entirely reactive. It's a very traditional management style, typically top down. There's typically not really any accountability for anything other than it's all hands on deck. Just get the cases or get the units out the door today. The second stage that you move to is where you have projects. So employees are starting to be involved at this point. You have maybe some KPIs in place, you have some training going, so you started your journey. Preventive maintenance would be an example of a tool that you would use at this stage, at stage two. Stage three is now you're starting to implement processes. So you're taking a lot of the tools that we're going to talk about today, you're starting to integrate those into the way that you do business. So your employees are going to be more involved in teams, for example. You're also going to get your employees involved in CI activities like Kaizen. So you're starting to see those types of terminologies that are going to be showing up in your workplace, on a daily basis. And lastly, that last stage, that stage four, that's when it becomes integrated into your culture. And that's the sweet spot. That's the spot that for me, it's like, oh my gosh, we did it. And I have been fortunate enough to be able to lead some companies through all four of those stages. And at the first stage, you think, oh my goodness, how are we ever going to get out of this? Because at the beginning, you're still having to do all your firefighting while you're trying to implement some of these new tools in a different way of thinking. And so it's busy and it can be somewhat stressful. And you think we're never going to have the resources to be able to support both of these things. But if you stay with it and you're consistent with using these tools, you'll start to flip a little bit. And the more that you start doing more proactively and start using continuous improvement tools, start measuring your progress, your firefighting then comes down and your more proactive activities end up going up. And by the time you get to that stage four, you have employees that are coming to you and saying, here's the problem that we had, here's what we did about it, and here's the impact that we had. And you don't even have to ask the questions anymore. And again, that to me is that sweet spot. So we're going to ask a question right now that I think is going to come up on your screen for a survey. And I would like to know, where is your company on your current CI journey? Firefighting, which is stage 1, project stage 2, process stage 3, or that it's part of your culture stage 4. So we'll give you just a couple of minutes to a couple of seconds to answer that question. Okay, and we'll see if we can get the results up now. So it's very interesting, and I think it's actually very, very typical. So we've got a lot of firefighting, and then a lot of companies that are starting down that journey. So about 70% of you look like that you're just starting the journey, starting to think about it. We've got a few companies then that are focused on process, and we've got one company that looks like they have integrated CI into their culture, which is amazing. And I would encourage all of you to share your experiences with one another when we get to even the question time. If you'd like to share your experience on what this journey is, I think that would be really interesting to share. Okay, so some of the tools that we're going to talk about today, and again, I don't expect all of you to say, oh my gosh, I've never heard of that before. These are all tools that are very common and are out there, have been used for decades, but oftentimes we forget that they exist. I would encourage you to think about, even if you're at, at that stage 3 or 4, think about one tool that you think, that's something that we haven't done in a long time, or that I'd like to try. I just need to get some focus on it to get it started. But just as we're going through these, think of, like I said, at least one tool that you think would really be able to, you would be able to implement into your business, tomorrow, really, and get started. So root cause failure analysis, or RCFA, that to me is a very fundamental foundation tool that I have used for a very long time. And in fact, I've used it in my personal life for many years. I have two grown sons who will tell you the story that when they were growing up, that word why became a dirty word in our house because I just used it so much in asking them questions. And people, once you start using this thought process of the 5 whys, you end up doing it without even really thinking about it. It's absolutely statistically proven that once you get to that 5th why, that truly is your root cause. And so many of us say, gosh, I got to the 2nd why, or I got to the 3rd why, and I think I've got it. But when you look at it from maybe an outside perspective, looking in on those problem statements, those problems that have occurred, oftentimes you haven't reached that true root cause. You think you've reached the answer that you thought it was going to be before you started the analysis. And once you really push through the entire process of the 5 why, you can see that it may be something completely different than what you had originally thought of. And that's the beauty of our CFAs and 5 whys. And then once you get to the end, asking, have I fixed it forever? Is there an opportunity for this problem, this issue to reoccur? And if there is an opportunity for that, then maybe we didn't get to the true root cause, or maybe our subsequent action plan that we had isn't specific enough. So, for example, if you have someone who maybe made an error out on the line, and you say this was operator error, and you've gotten to your 5 whys, and okay, yes, that's what it was. And so many times the response that we give back is we're going to retrain that person. Well, I can tell you, I've never accepted retraining as anything I want to see on an action plan for root cause failure analysis, because if they've already been trained once, there was a reason why that information didn't stick. Either the training was not developed correctly, it wasn't communicated correctly, perhaps the trainer wasn't a good trainer, perhaps the operator never got an opportunity to practice the skill that they learned before they were just turned loose and told to go do it. So there's lots of other reasons that could have impacted that operator's ability to be able to retain that information that they learned in their training. So doing that again is not going to change your result. So if training was the issue, then let's figure out what in the training, didn't go as well as it should. So that's what I mean about pushing beyond what is very obvious to you. Root cause failure analysis shouldn't be used all the time. I typically will set a parameter. So it might be that you have an hour of downtime or more, or it might be 30 minutes. It might be 10 minutes. It depends on where your baseline is that you're starting. It might be that you have any quality holds. or any safety issue that you have, you would do a root cause on. But you have to set those boundaries of when will you do them. Otherwise, you could do, 10 of these a day, and certainly the impact gets diluted. Part of the root cause failure analysis program is this proverbial fishbone diagram. I think most people are very familiar with this. I think it's a very good tool to learn how to do it. And once you start doing them, you will think through all of these questions in your mind without even having to write it down or to do, have a team meeting about it. But for example, you would have product losses, you'd have some loss that you had, and then you would go back through and do all of your 5 bones on the fish. And it helps you just to make sure that you didn't forget something. It also helps you to make sure that you're validating the things that are not the problem. And so what's left, that's what you do your root cause failure analysis on, of course. But the things that are not a problem, it's also good to know that and to make sure that you can, yes, check that off as we're good with that. The next tool we're going to talk about is value stream mapping. So really, value stream mapping is about optimizing your material flow. And it doesn't necessarily have to be raw materials. It could be a lot of different things. It could be people. It could be equipment. It could be actually ingredients. So we want to look at our entire supply chain, really. I have one of the clients that I work with, and they are a large, almost like a millwright manufacturing shop. And they were starting to do some work for a customer point A to point B, but there's lots of times where they would have roadblocks that would come up and they would have too many of a certain part of the assembly in one spot, and it just shut everything down. There was other times in the process that things were so open that people couldn't, they were just waiting for something to come to them. So we did a value stream map on that. And we looked at what are the things that we can control. And then we started to put emphasis on what are the things that are non-value add. So for example, we'll look at this. If you have a forklift that makes a trip from the warehouse empty, for example, that would be considered to be a non-value added activity. If you're on the highway, your transport truck returns empty. So when you're looking again at your entire supply chain, that would be something from a transportation perspective that you may want to investigate. Or let's just say that you have a maintenance person that walks to the storeroom to get parts repeatedly, as opposed to having a world-class maintenance program where you have a work order planner in place and they have all of the parts gathered together and put in a bin. The maintenance person gets the work order with the parts and they've got all the tools they need. They go do the job and come back. So those are the types of things that you want to try to get to when you're looking at a value stream map. So when we say movement of material, again, it doesn't necessarily always mean raw materials, but this exercise is really, really valuable. And I just can't stress that enough. I feel like oftentimes we make assumptions about how a process works. When you actually validate that and you start to document that process, you realize that, gosh, things aren't really working the way that we thought that they were supposed to work. And so value stream map will point those things out and it will drive those efficiencies. Waste reduction is another tool. So how much is too much? That's always a question. I get that oftentimes. World-class in food processing plants is less than 20%. So that's considered to be world-class. I remember one time I had a client that it was a bakery. They baked bread. And I was just getting a plant tour the first day, and I walked into their spiral cooler room, and there was bread all over the floor, literally up to my waist. And I was quite taken aback. And they said, "Oh no, this is all normal. This is just part of what happens. We get a jam up there, and because there's no place for the bread to go, this is just what happens." And I thought, oh my goodness, we're accepting that as just part of the way we do business, and it's just part of the cost of doing business. So I really challenge those types of assumptions. Is it possible to eliminate all waste And the answer I would say is yes. Even if you're taking what's considered to be sub-quality and selling that in a different way. So, for example, I was out in California on vacation a few years ago, and we went through Jelly Belly plant, which was very interesting. I'd never been through a jelly bean plant before. But one of the things that they do is of course, at the end of the tour, everybody goes to the gift shop, and they had a huge bin of, they called them Helly Jelly Bellies. And they were, I think that was the name, and they were seconds, basically, jelly beans that didn't meet the quality specs that they had for their first pass quality. So they just bagged them up and sold them at a reduced cost. So did they eliminate all waste? That was certainly one of the ways that they eliminated the waste of their seconds instead of throwing it away. Or if you are maybe a company that makes cakes, for example, can you take the cakes that maybe turned out a little bit too dark and grind the cake, the baked cake, and then you put that back into your batter at a very small amount that's never going to affect the quality of the cake, but you're able to use that as opposed to, throwing it into the garbage. So eliminating waste actually can be done, and using Kaizen teams, which we're going to talk about in just a minute, using very focused teams will certainly help with waste reduction. Changeover reduction. This is, I think, the engineer in me. I love this tool, the single minute exchange of dies. When I was designing equipment, it was something that I always had in my original design, was how can we make the changeovers, it might be a bottle size change, it might be any kind of a unit size change. For example, you may have conveyor belts that have guides on the sides, and instead of loosening bolts and I call it the tap tap method, but you're just kind of squeak those sides on your changeover, you would actually in and then off you go. And it really, really helps to reduce changeover time and makes them much more efficient. So if you are a business that really changeovers are just part of what you have to do in your business, of course, reducing the number of changeovers you do can certainly have a significant impact. But sometimes, based on customer requirements or equipment capabilities, we have to do these changeovers. So we have to get good at doing them well. So the SMED tool is extremely helpful, and I would encourage you to look for those types of opportunities, because a lot of times they can be very inexpensive. They pay for itself very quickly. Spaghetti diagrams, looking at tasks. So changeovers are oftentimes very chaotic. And if you can do a spaghetti diagram, and I use just a regular video camera, cell phone camera, and you just can videotape an actual changeover as it happens, and you will see people just moving all over the place. And then they might stand there and wait for somebody to do something else, and then they take off, and then you've got all these people, as opposed to understanding how long that changeover should take, assigning everybody specific tasks, assigning them a time frame to get those tasks done. You've got the tasks being completed in a certain order so that everybody's being used, most valuably. So changeover reduction using tools, as opposed to just saying, do better, do it quicker, can be very effective in reducing your costs and reducing your downtime. So Kaizen, I mentioned that just a few minutes ago. I'm a big believer of Kaizen. In fact, I just led a Kaizen event last week for a client that I'm working with. It can be extremely intense, but it also can be extremely impactful. And for those of you who've done them before, they can, by the time those 2 days or 1 week is finished, you can typically be very exhausted because it is very intense. But you'd start that event by setting a SMART goal. You would make sure that you've got cross-functional support there full-time, not people kind of coming in and out, but people have set aside a full day In some cases, I like to do maybe 3 hours in the morning, give people even a 2 hour break that they can go answer their emails and do their other work, and then come back for another 3 hours in the afternoon. Sometimes you need to do that, just to accommodate people's schedules. But the Kaizen targets that you would use, the processes that you would work on, are typically a little bit more complicated. So it might be something, I don't know how many of you do like maybe a weekly team meeting on something, but if you think about it, the first 10 minutes of that weekly team meeting, you're kind of catching up to where you ended up last week. And so you lose some time doing that, but with less complicated issues that are being worked on, that might be perfectly fine. A Kaizen, it's when you're thinking, we don't want to think about anything else. We have to go from one thing to the next in order to really be able to solve this particular issue. So the Kaizen really is about being in the actual place. So yes, you're going to have some time in a conference room, but you're going to have a lot more time out on the production floor where the issue is happening. It might be at receiving, it might be at shipping, it might be in the maintenance shop, it might be, in your packaging area, your baking area, whatever that it is. But you'll spend a lot of time out there because you're actually making the changes that you're able to right then and there. So it's very timely. And you're going to use facts and data, just like we do with all of our continuous improvement efforts. I put this, don't be a bull in a china shop, because you really have to be careful when you do a Kaizen and you are moving a group of people out to the floor to work on something. It can appear to the people who are in that area, oh my gosh, this huge group of people, they're coming out with clipboards and they're coming out with stopwatches, and what are they doing and why are they doing this and how is this going to impact me? So making sure that you're communicating well and planning that event is very important to the success of a Kaizen. 5S, I'm going to go through this fairly quickly, but I do think it's worthwhile to mention because many companies that I work with, I'll ask, do you have a 5S program? And the answer is yes. And when I do a plant tour, I will see the paint or the tape on the floor where the garbage cans are, and I'll see some shadow boards or some cleaning tool hangers on the walls. But that last S is the one that always gets us in trouble, that's sustain. So just as a quick review, sustain to me really means that you have to keep doing something. Once you implement all of those previous S's, when you get to that fifth S, you've got to keep it going, because if you don't do some of these things that I've got listed there, it will just erode away, especially when people get busy, when people are focused on other things, it will go away. And I see that happen a lot. So I just want to remind everybody to be focused on that last S of sustain and get creative with how you're going to do that. The next tool is SOPs, or standard operating procedures. People who have worked with me know that I must say the word documentation at least a dozen times every day, because I'm a big believer that you can't train using what I call the osmosis approach, where you just kind of put one good operator with the new operator and say, teach them everything you know. It never works. It does not work well at all. You need to make sure that you've got the documentation. And the documentation really should be less words, more pictures, more prints, screen prints, and it should be making that it's updated. So you want to make sure that it's on a schedule to be checked and reviewed. But everybody should be doing everything the same way. And we in leadership oftentimes assume that that's happening. But I guarantee you that when people are finding shorter, quicker ways of doing things, that SOP will erode over time unless we get everybody regrouped and recentered again. It's almost like center lining your work steps that you have. So if you have not done a standard operating procedure on all of your key procedures, I would encourage you to do so. This is just a template of one that I've used in the past. So you can see there's a description. but also you've got pictures of the tool that that you might need to have, or you've got a location on the equipment that you've got a picture and it's identified. So just get a very simplified, it can be on an Excel spreadsheet. It certainly does not need to be fancy. And then you'll be able to fill that in and use that every time you train an operator, a mechanic, whatever it might be, in that particular procedure. So we're going to flip a little bit to preventive versus predictive maintenance. And this is something I got from MRO Magazine again, that says that right now, about 45% of people use preventive maintenance in their facilities, which is great. Certainly better than nothing. About 33% are focused on predictive maintenance. And that is amazing. I'm a huge fan of predictive maintenance. And about 20% of us are using that run to fail, the firefighting strategy. I would say this is a pretty optimistic response that we got back, because I find that there's probably more companies, if they were really honest, that use the run to fail strategy. So any unplanned downtime would be considered to be a run to fail strategy for that particular area, piece of equipment, or department, what have you. So preventive maintenance, as we know, is frequency based. You're going to do that task regardless of whether or not you need to do it, but it will be done at the same frequency all the time. So this is some of the information that you would expect to see on a preventive maintenance work order, for example. And having all that information is very important. That's really a key role of a work order planner, is to take this information and really to develop it. So the detailed tasks, having pictures of, maybe a go, no go picture, having measurement. So instead of just saying, we're going to go in and we're going to change that part, whatever that it might be, that you're saying to them, the parts are available, they're ready to go, and you've got it. And yes, we're going to change that part once a month, whatever that it is. So that's preventive maintenance. And again, I do think that it is better than nothing, but the best is the predictive maintenance, in my opinion. So you're only replacing that part, that in that example I just gave you, when it is needed. So you're going to take a measurement. Let's just say that it's replacing a gear, that you would actually have your maintenance team measuring the ID of that gear, the shaft, to see when it is worn enough that it starts to wobble on a shaft, and then that would be the time that you would replace it. So that would be an example of predictive maintenance. You're using data to drive when you're actually going to be doing certain tasks. The cost of it can vary by what the technology is. I've got a slide here that shows which technologies, and you've got thermography there, oil analysis, vibration analysis, many different tools, and then the application for those. So how are you going to use those when you're looking at an electric motor? Which of those tools can you implement? I always find that some of, like, oil analysis for me is a great one to start with if you've not started a predictive maintenance program and you're looking to do that. It's fairly inexpensive because you typically don't have to make any kind of a capital investment when you're doing oil analysis. You are just taking samples and sending them to an outside lab who would then run the analysis for you and send back graphs that show particulate matter, concentrates, and things like that. The viscosity, all of that, for example. And in thermography right away, they will hire an outside company to come in and to do that for them. So again, the investment on that could be fairly low, but the payback on all of these predictive maintenance technologies, the ROI on them is very quick. So once you feel like you've got a good handle on your preventive maintenance work orders and that process, migrating into predictive maintenance is a fairly can be a really quick transition once you've got that fundamental baseline for your preventive maintenance program. So I'd like to ask another question. How is your company measuring downtime and uptime? We're going to talk a little bit now about measurements and how to do it. So do you typically use efficiency calculations, OEE? You're not measuring it at all currently, or some other method? So if you could take a minute and just talk about that, check that off on where your experiences are currently. Okay, take a look at our results now. So many of you are using efficiencies. OEE is great. I'm really glad to see that. We've got one company that's not currently measuring it, and that is not uncommon at all. And then we've got a couple of other technologies that are being used, and that may be industry based, focused. I'm not sure. But we'll talk a little bit about efficiency and about OEE today. So your efficiency calculation, again, it's better than nothing. It's better than not measuring. The problem that I have with efficiency is that it can be easy to manipulate. And when I say that, we oftentimes will dismiss issues as just part of the way that we do business. So we may say, oh, well, yes, we're going to shut down for lunches and breaks on the line. So that's just part of business. So there's no need to measure that. And you will not capture things like that in your efficiency calculation, because you're typically calculating based off of how much time are we scheduled to run versus how much time did we run. That's really what efficiency comes down to. It doesn't take into account, though, the planned versus unplanned downtime, because in some cases, your planned downtime, like lunches and breaks might be a good example of that, can kind of erode over into becoming some unplanned. So if you had 30 minutes down for a lunch break, but by the time the operators start wandering away from the line and they stop and they talk with their friend on the way to the cafeteria and they have lunch and then meander back, the 30 minutes is really 40 minutes. And so what you had dismissed as lunches and breaks, all of a sudden you're not really taking into account the opportunities that you might have to take some of your planned downtime and make that even more efficient. Efficiency calculations can encompass labor, waste, and inventory, which is, again, a good thing. OEE, on the other hand, though, takes into account a lot of those things. And so I really like this chart because it's very easy to explain what each of the components are for OEE. And we'll go through those. So when you look at planned downtime, so again, things like I mentioned, lunches and breaks or meetings, shift changes, change outs or changeovers, planned maintenance or PM time, CIP or SIP for those of you in the beverage industry, those would be considered to be planned downtime. Unplanned downtime would be breakdowns, of course, jams that you might have, maintenance extensions, or if they're in the middle of doing a PM and they say, oh my gosh, while I'm in here, I'm going to do these other things because I see them. Waste or rework, any kind of an adjustment to pieces of equipment. I know many of us at the end of the day are like, oh my gosh, what happened to my results today? And until you dig in, you don't realize that the operator just turned the speed down, either accidentally or thinking that they were doing the right thing. So those would all be considered to be unplanned downtime. So downtime loss examples for our OEE calculation would be some of those things that I have here. Even things like startup time. One of my clients, I recently helped them to implement just a regular, very simple whiteboard at the beginning and the end of their line, where they were keeping track of their bottles per hour and their cases per hour at the other end. And there was a very clear trend as they started to fill these in every hour, that the first 2 hours of the shift every day were always in red. They never met their goals. And it's because it's that startup time. So now we know what to do, where to focus. If you're just looking at one number at the end of the day, or worse, at the end of the week or at the end of the month, it's sometimes difficult to identify things like that. Then you've got availability. Availability with the planned and unplanned downtime, like we just talked about, but there's also the people factor. So breaks for people or fatigue factors. Do you find that as the shift goes on, maybe you're running a continuous 24/7 shift and they're working 12 hours. The last 2 hours, people are exhausted. Do you time washroom breaks? It seems silly. It seems like a silly question, but are you having breakdowns? Are you having downtime because of washroom breaks? Perhaps. If so, how can you manage that a little bit differently? And who does that? Who decides, what you're going to measure? This part of the OEE calculation, the availability part in regard to people, can be a little bit more subjective than when it comes to equipment and machines. Then the performance piece of OEE. So that's based on the OEM design speed. A lot of times we say, oh, well, we're running 100 bottles a minute, whatever that it might be. And in reality, that equipment was designed to run 150 bottles a minute. So it's the 150 that you need to use in your calculation as your baseline. So if you're only running 100, you've got upside, obviously, and that will show up in your OEE calculation. Having standards for everything, so knowing what those standards are and making sure that those are clear and that everyone's using them. For example, that bottle calculation I just shared. So some of your performance loss examples that you would have, I've put up here. Things like a sensor might have been blocked. You might have had equipment wear. Those types of things you would want to be investigating, and they will show up again in that OEE calculation. And then the last part of the OEE calculation is quality in finished goods. So first pass quality is the standard that you're going to use. Any waste that you have on your finished goods are deducted, and that becomes your opportunity as it is would show up as part of your OEE calculation. Here's some of your quality loss examples that you might have. You might have, for example, if you're in the beverage industry, you may have temperature variation. So you produce good product, you put it in the carton properly, and then you get some kind of downtime on the line, and now the temperature of that product has exceeded spec, and so it becomes waste. That would be an example of a quality loss that you would have for OEE. So when you do implement OEE, and for those companies that are already doing that, I'm sure that you had to have somebody who drove it, who owned OEE. So I think that's really important. It does take, what in my experience, about 20% of a production or a maintenance supervisor's time to be that champion of OEE. Driving it out to the floor is very important. That's why I like using those whiteboards. So the first thing is they're keeping track of their cases per hour. The next step will be then having them start to keep track of the waste, and then they'll start to calculate their own OEE out on the production floor. That's moving up toward changing your culture. That's that stage 4. So ask yourself the things that you're currently measuring, is this a useful measurement? If you're measuring efficiency, is it useful? Is it driving action? Is it driving results somehow? So before you decide that this is our KPI, really ask yourself if it's worth measuring, because sometimes it can take some work to measure KPIs. And if it's just something that's going into somebody's computer or getting put into a spreadsheet somewhere or reported to corporate, but you're not really using it every day, I would challenge you a little bit to say, is there something else that maybe we could be using that we could educate the people on the production floor, how it's calculated and how it drives meaningful change at the facility. Some other KPIs that you might consider might be cost per case or labor cost per case. That is one thing that OEE does not really touch on, is that labor cost per case. So that might be another KPI that you would use to complement either your efficiency or your OEE. So I will finish up by saying that maximizing uptime requires consistency. So those bullet points that I have there saying people are too busy, or I don't have enough people to do this, I don't have a budget, I don't know how to do it. Really, I would challenge you just to say, gosh, anybody can use these tools. Anybody can put a predictive maintenance program in place. Anybody can make sure that they're measuring the right things and using that to drive decisions every day. So please don't get kind of sucked into thinking that I'm not big enough, don't have the resources, I don't have a corporate office to support me. Please try to really challenge yourself to, like I said, pick one tool that you heard today and say, that's the one I'm really going to go after. So with that, I will open it up for questions.
Anyone has a question, you can put it in the Q&A box at the bottom of your screen. So one question. How do you balance the need for downtime for maintenance with the goal of maximizing uptime in a food and beverage manufacturing environment where hygiene and quality control are so critical?
I think that's a really good question. And again, it would go into that making your planned downtime as efficient as you can make it. So if you have to do changeovers, for example, if you have to shut down to do quality swabs, if you have to shut down to, run some kind of a trial or a test, make sure that you are looking at that time, that if that swab is supposed to take 5 minutes, of downtime, and you start to measure that, and you realize that the 5 minutes is really 10 minutes by the time you get a quality tech there, and then they do the swab, and then they go back to the lab, and then they get the results, and then they communicate back to the line. Yep, it's okay, go ahead and start up. Yes, those are things we have to do, but how can you make that process more effective and more efficient? So looking at that planned downtime and not just accepting it as that's the way that we have to do business, but looking at it as an opportunity to try to do it as efficiently as we possibly can.
Okay, there's another question here. What are the most impactful innovative technologies and uses of those technologies on uptime?
I think that there's many, many technologies. Like some of those I mentioned today. I know we've got two presenters today to talk about some AI options, and those are very exciting and new. And those are things that the old school in me, I'm anxious to learn more about, because I think that many of them are things that aren't integrated into the way that we do business. But the technologies that I really believe in really are these basic grassroots tools. And are they highly technical? No, but that's what I like about them, because I think those have the opportunity to have the biggest impact, because you can involve your entire workforce. You can involve the production floor. You can involve the forklift drivers. You can involve your maintenance staff. And if you can have 10 people or 1,000 people, however big your facility is, but 100% of your people working on some of these tools, I guarantee you will see drastic results fairly quickly. I always say to people, pick that one thing that just drives you crazy that you have to fight every day, and work on that using a tool. Don't just do better, but work on using a tool. How do we eliminate that one fire? If we put out all those fires just by each person picking one, imagine where we're going to be. And that's kind of how I try to get people motivated and empowered to really be a part of that change.
Thank you so much, Kim. It was such an insightful and so much practical advice there. So we really appreciate your time.
Thank you so much for having me, and I look forward to the next couple of presentations.